Hello everyone, I'm Santosh and I welcome you to my channel Learning Bits. And in this video, we're going to discuss how exactly we're going to draw a color cube and we are going to spin the color cube using OpenGL transformation matrices. So rather than using OpenGL transformation functions, the inbuilt functions, we are going to make use of the transformation matrices and we are going to spin the color cube, what we are going to design and what we are going to display. And so now, whenever I want to draw a cube, I need to have this 8 points. I'm going to have this as the point 1, point 2, point 3, point 4, and this is the point 5, point 6, point 7, and the point 8. And so these are the 8 points which I'm going to use. And if you observe, each point is going to contain 3 values, which is going to be the x value, y value, and the z value, what I'm going to use to draw a cube. And so once this cube has been drawn using OpenGL program, using OpenGL transformation matrices, we are going to rotate this cube. And this is what we are going to do. We are going to spin the cube using transformation matrices. If I want to rotate with the z axis, we are going to use this matrix. That is, now if this is a cube, this is going to be a cube, and if I'm going to have, this is going to be my z axis, and this is my x axis, and this is my y axis. And if I want to rotate the cube in this direction, either clockwise or anti-clockwise direction, if this is my rotation, then the x-axis will be the rotation axis. That is something like I'm putting a stick inside the cube with parallel with the z-axis and start rotating the cube. This is what we say, the rotation of the cube or the spinning of the cube with respect to z-axis. And if I talk about x-axis, so keep the x-axis as a stick now, a parallel with the x-axis, and start rotating the cube either the clockwise or the anti-clockwise. And this is what we are going to call this as rotation with respect to x-axis. And if I'm going to talk about y-axis, so keep the y-axis like a line or a stick and start rotating the cube in this way. Either we are going to have counterclockwise or the clockwise. This is what we going to talk about, the rotation with respect to axis. So the z-axis rotation or the spin, and the x-axis rotation or the spin, y-axis rotation or the spin. And sometimes I can bring in both the x and y axis or y and z axis in combination. When I say x and y axis, so it will rotate in this direction in between the x and the y axis. Whatever I'm going to is going to rotate in between. This is what we're going to bring in the transformation matrices. Use the transformation matrices to spin the cube. Hence, now this matrices I'm going to put in the form of equation. If I want to have the z rotation, the value of z will be same. That is the new point, what a rotation point I'm going to find. The new value of x will depend upon the original value of x multiplied with the cos theta minus the original value of y multiplied with the sin theta. So similarly for the y value, I'm going to have x sin theta and y cos theta, and z value will be intact because the rotation will be with the z axis, hence the value of z will not change even for the rotation also. And if it is x axis, I'm going to have x axis intact, and I'm going to find the new value of rotation for the y and the new value for the z, and I'm going to have the y value to be intact in the y axis rotation and find the x value and the z value using this equation. This equation has been formed by using this transformation matrices, and this is what we are going to use in our program to apply the rotation. So we will bring in this equation into program, but the first job is you need to create the color cube, display the color cube, then you are going to apply the transformation matrices. Hence, as the first step, you need to include few header files and you're going to have the main function. And now using this main function, in this main function, so let us have the APIs, the essential APIs, something like the first API should be GLUT init, and I'm going to have address of argument C, comma, argument V. This is the very first API to initialize my program with the graphics environment. And I just want to initialize my window size, and so I'm going to use GLUT init window size, and I just want the window size to be 600 comma 600, and I'm going to have GLUT init. So if you want to know what all this API is going to do, the basic APIs, you can just look my previous video, which I've given you the detailed information about what all this is going to do, what this APIs is going to do with. And so the essential APIs which we are going to use to set the position, I'm going to set the position. So once I'm going to set the window size, the window position, so now I'm going to set what the display mode is going to be. And then display function, I'm just going to have GLUT init, so display mode. I'm going to have GLUT display mode, and in display mode I'm going to have the RGB color model. So I'm going to have bitwise OR operation. So I'm going to have a 3D object as a cube, hence I need to use the double buffer, and in this double buffer I've got two buffers. Out of this two buffer, I'm going to make one buffer to be the depth buffer. And so once this is done, I'm going to create my window, and so GLUT create window, and I'm just going to pass the parameter for this, the title of my window. And so let me give this as so cube spin with matrices, fine, and my window will be created now. And so once the window has been created, I need to call the callback function. So GLUT, so display function, which takes a callback function. For example, let me use this as draw. This can be any of the user defined function, and I'm just going to have GLUT main loop. I'll be having GLUT main loop over here. Now this is going to be my main function. So with this main function, I need to do some initialization. That is, if I want to set the background color, or if I want to set the color which I'm going to draw, I can do in myInit function. Hence, I'll be using myInit function whenever I want to initialize anything of my choice. So it's better I'm just going to use my initialization function, which is going to be a user defined function now. Hence, I'm going to define this as void my init. This is just user defined function. You can give whatever the name you want. And for in this function, I'm just going to set in what color the background should be. Hence, I want my background color to be of white. Hence, I'm going to give this as 1, 1, 1. By default, it's going to be white. So let me make this as black color, and the transparency, let me make it as alpha value to be 1. And this is going to be the GL clear color. And the drawing color, I'll just see it later, but this is what exactly I need to initialize. And with this, whenever I'm going to have GL depth, I need to activate the Z buffer. Hence, I'm going to have GL enable. If I don't activate the Z buffer, you will be not able to see the back faces of the cube. And so GL depth, be having GL depth test. I'll be using GL depth test to enable. So if I'm going to have this, now I'll be able to see the back face also. This is what the initialization, what I want to do. Hence, I'm going to have main function, and I'm going to have myInit function. Fine. So once this is done, I'm just going to have this draw function should be defined, or this draw function should be defined with this body. Hence, I'm going to have void draw, which takes no parameter, I will just open this brackets. And now in this draw function, usually the first function is going to be GL clear, and so I'll be using GL clear, and I'm going to clear two buffers now because I'm using GLT as double buffer, and so I need to clear two buffers here, and so I'm going to have GL, so the color buffer, and so GL color buffer bit, as well as I am going to clear the depth buffer also, the second buffer what I am using, and so GL depth buffer bit. I am clearing both the buffers, and so I am using two buffers, and so whenever I want to put the content to the frame buffer, I'll be using GLUT swap buffer, which will fill the content into the frame buffer immediately. If I don't do this, so you will be not able to see your applications or your program code to be reflected in the frame buffer. Hence you need to use GLUT swap buffer. So in between this is where I am going to draw the cube. But before I am going to draw the cube, I am going to initialize the points for this. I need to have the 8 points. And first let me bring those 8 points into the program using a data structure. Let me close this manager view so that I am going to have good area to use this. I am just going to use the data type what the OpenGL is going to have, and so I'm going to have it as GL float, and I need to store 8 points, and so I will just say V, which I am using for vertices. I am going to have 8 vertices to draw a cube, and I am going to have 3 values for each vertices, or I can say I am going to have 8 points to draw a cube, and each point is going to have 3 values X, Y, and Z, and I'm going to initialize this. I'll be initializing this array, and so I'm going to use the array initialization technique. And I hope you are clear with this array initialization technique. And just for programming structure, I'm just creating this structure so that I'll be able to clearly identify which is the first point, the second point, third point, and so on. And so now I need to have the first point over here. Now just look at the cube points what you're going to have. So before you can start this, you need to have what the point is going to be. And for that I'm just going to have a cube. Now we can just look at this. This is the cube what I'm going to have. So in this cube, I'm just going to have this 8 points. This is the first point what I want here. You can pick any point, but you need to go in a order, either in a clockwise or in a anti-clockwise. Do not go in a zigzag order. You can see the first point is going to be minus 0.5, 0.5, and 0.5. And so I'm just going to fill this minus 0.5. So comma, so 0.5, comma, 0.5. And this is the X value, Y value, and the Z value of the first point. So comma, so is the initialization for the first point out of the 8 points. So similarly, we'll do it for the second point. Now the second point is going to be 0.5, 0.5, and 0.5. Hence all the 3 values going to be 0.5. The second point is done. And I'm just going to now pick the next point, so which is going to be 0.5, minus 0.5, and 0.5. So 0.5, minus 0.5, and 0.5. So I'm going to have the fourth point now, so which is going to be of the front face, which is going to be minus 0.5, minus 0.5, and plus 0.5. So this is the 4 points of the front face of the cube. So similarly, I need to have the 4 points of the back face. If you just carefully observe, now this front face X and Y value and the back face X and Y value are similar. Hence, I'm just going to copy this. Only the Z value is going to vary from positive to negative. Hence, I will just copy and paste this over here. Now, all the Z values should be minus 0.5, minus 0.5, minus 0.5, and minus 0.5. And the X and Y value will remain same for the back 4 points of the back face. Hence, this is points what I'm going to have in my program. So once this is done, my next job is I need to use these points and draw a cube. Hence, for that purpose, whenever I want to draw a cube, I'm just going to call the function as cube. I'm going to develop a new inbuilt function or an user-defined function rather than calling it as inbuilt function. I'm just going to have this as an user-defined function. So where this function is going to have all these points as a parameter. I'm going to pass the first point as a parameter, the second point as a parameter, and so on. And so I'm going to have this is going to be the first parameter is the first point, which is v of 0. Second point is v of 1. The third point is v of 2 and v of 3, v of 4, v of 5, v of 6, v of 7. That's done. So this is the 8 points what I want to have to draw a cube. So once you are going to have 8 points which I'm going to pass to the program, so now I need to have the method called as cube, which is going to accept those 8 points. Hence I'm going to have GL float, so v0. So let me name this as v0. So comma. So similarly I'm going to have all these 8 points now. And so I'm just going to put 4 times 5, 6, 7, 8. And now this is going to be the v7 because I'm passing 1 point. So from the cube function as a parameter, hence this should be a single dimension array now. Hence I'm going to have v5 here. This is v4. Now this is a formal parameter. You can make use of any name over here, but just for my reference sake, which makes my job easier, when I'm going to have such names, the naming convention will help me out to have a good programming structure. Hence I am passing v of 0 here, which is the first point. The 3 values will be stored in this array v0. Hence v0 will have the first point, v1 will have the second point, v2 the third point, v3 the fourth point, and so on. And the 0, 1, 2, 3 are not the index value. This is part of your variable or the array name. Hence once this is done, I'm just going to open the body of this cube function. And inside this cube function, whenever I'm going to have a cube, if I'm going to have a cube, now each cube is going to be a square or a rectangle which is made up of 4 points. This is made up of 4 points. The back face is made up of 4 points. The left, the right, the bottom, the top, all this are all made up of 4 points. Hence, so rather than putting everything is going to be in the cube, I can do this using combination of these 8 points. I can draw all the 6 faces in the cube itself. But instead of doing that, as a good programming structure, let me define a function called as face. I'm just going to have a function called as face. Now where this is going to be an user defined function again, which we should define later. And now this face function is going to draw me a square or draw me a rectangle. Hence this should take 4 parameters. Now eventually if I want the front parameter, something like this value, what I'm going to have, it is I'm just going to have the front face is going to be now v0, v1, v2 and v3. Hence I'm just going to have this as v0, the first point, and v1, the second point, v2, the third point, and v3. Now these 4 points will make up my first face of the cube. And so now to have this first face of the cube, I'm just going to build this user defined function, so which is going to take 4 parameters. Hence I'm going to have this as face and GL float a, and I'm going to have GL float b, because I need to have the 4 points. Hence I'll be storing this as ABC. I'm going to have GL float C, GL float D. I'm going to have this 4 points to draw a face. And now whenever I want to draw a face, it is going to be a square. Hence I'm going to use GL begin, and inside this GL begin I need to mention this as polygon because I want to have a solid face. I need to have a solid interior as a face, hence I need to use the GL polygon. If I just want only the outline, only the wireframe cube, I would use this as GL lines or GL line loop. But I just want a solid cube, hence I am going to have the solid face with GL polygon, and I am going to end this. So now if you want to understand what all this GL begin GL end is going to be, you need to watch the previous video which I have shown you the basic structure of OpenGL program, or my first OpenGL program. You need to have a look at that video to understand in depth how this API is going to work with. And now when I'm going to have this as GL begin and GL polygon, I'm just going to have the vertex, so GL vertex, and I'm going to draw a 3D object. It should be 3, and I'm passing floating point values, and it should be floating point values, and the points whatever I'm going to have right now is going to be in array, and so I'm going to use this as V, and the very first point of the face is going to be A, and so V0 is stored in A, and so I'm using A as the first point, or the V0 as the first point to draw the front face. I'm going to copy this, so paste it 4 times, and this is going to be the second point, and this is going to be the point 3, and this is going to be the point 4, and this is going to be the face value. Now whatever the 4 points you pass as a parameter, it will just accept those 4 points in the form of A, B, C, D as array, and uses V, the vertex, in the form of array as a parameter, and it's going to draw me a square or rectangle to draw the face of the cube. Hence now this is going to be my first face, and similarly I need to have 6 faces of the cube, hence I'm going to call the function 6 times. And now just look at this. The front face is going to be with 0, 1, 2 and 3, and the back face is going to be made up of 4. You can start from any point, but go in a clockwise direction, in a one direction, or in the counterclockwise direction, but never go in zigzag. Don't use 0, then 2, then 1, then 4. Just go in order. Hence I'm going to have the back faces 4, 5, 6 and 7. Hence I'm going to have V4, V5, V6 and V7. So let me comment this out that I can easily understand. Now this is going to be the front face, and now this is going to be the back face, and now I want this to be the left face, and I want this to be the right face, and I want this to be the bottom face, and I want this to be the top face. And so now just look at the points for the left. The left face is made up of 0, 4, 7, 3. Hence I'm going to have 0, 4, 7 and 3. This is going to make my left face. And if I talk about the right face, then I'll be having V1, 1, 5, 6, 2 or 1, 2, 6, 5 in any order. So 1, 5, 6 and 2. And the next, if I talk about the bottom face, then if I take up the bottom face as a reference, then I'll be having 2, 3, 7, 6. And so I'll be having this as 2, 3, 7, 6. And the top face is going to be 0, 1, 5, 4. 0, 1, 5 and 4. Now this should be able to draw me a cube. But now just observe this cube. So I talked about not just a cube, it should be a color cube. That means every face of the cube should be of different color. This is where we call this is going to be a color cube for you. Hence, to have a color cube, we are going to use the function, so GL color 3F. I'm going to use the GL color 3F function. And now let me draw the front face to be of the color red, Hence I'll be using this as 100, which will make me this as the color red. And the next face, the back face, I want it to be in some different color. So let me put the back face to be in the color green. And the left face, I'm just going to make this to be of the color blue. Fine. And now what about the next face? What I'm going to have? The right face I'm going to have. So let me make this combination of red and green. And let me make this as the combination of red and blue. And let me make this as the combination of green and blue. This green and this is blue. Fine. So now the color has been set, the face has been set, and so now my cube should be ready to be displayed now. And so let me just execute this program and see what I'm going to get as output. I have compiled. I hope there is no any errors, and I'm going to execute this. Yeah, I've just got a cube. But I'm not able to see any other face of the cube. I am able to see only the front face. I'm seeing only the front face, and all the other faces hidden behind the front face. Now I should be able to see the back face. How now do I do this? I am going to bring in the spin function to the program. And to bring in the spin function to the program, you need to use the idle callback function. Along with the display function, we need to use the idle callback function. And so GLUT idle function, and let me use a function called as spin. And again, this is going to be a user defined function. You can have the user, you're going to have spin as a user defined function. You should define the body for this function, how the spin is going to happen. Hence I'm going to have spin function, and this is going to user defined function as I said. Hence I'm going to have void, and I'll just say spin, and I'm just going to use whatever the value I need to change in the spin operation. I'm going to put it over here. So we'll see it later what exactly I should fill into the spin function. But now when I'm going to have a cube, now if I want to rotate this cube, what you should use? We are going to use the transformation matrices. So with respect to z-axis, if I want to spin or if I want to rotate, I'm just going to make use of these functions. Using these functions with the z-axis, we should be able to spin the cube with z-axis. Now let us bring in this equation to my program. And so now I have got the original points. So the original points V, which stands for Px of the first point, and the second point, third point x value. And so I'm going to, if I say Px, the first point, which is V of 0, and I'm just going to have this as the x value, y value, and the z value of the very first point. So similarly, I'm going to find the y value and the z value for the first point, and later I'll find the same operation for second point, the third point, the fourth point, and so on. For each point, I need to apply this equation. And now first let me spin this in the z-axis, and to make this to happen, I'm just going to use a new, I just need to define a new array where I can store the new rotated point. And let me call this as RV. And again, I need to have 8 points, and each point is going to have 3 values. Now I need to compute what this points is going to be. Hence, so RV, so because I'm going to rotate this with the z-axis, hence I'm going to have RV of 0. I'm going to find the first rotation point and the x value. Find the first point of the rotation value and the x value what I'm going to have. And this is going to be equivalent to, so I'm going to have the original point, which is going to be V of 0, the first point what I am taking and the x value of this, and I need to multiply this with, I'm going to multiply this with, so cos of theta. Now what this theta is going to be? It is going to be some angle, or it is going to be some data. And for example, if I want it to be 45 degree, I'm going to use this as 45 degree over here. But when I'm going to use or any parameter for the cos theta, it is not just going to be an degree value here. So I need to convert this to radians. So now whenever I'm going to have this as an degree, this 45 degree what I want to rotate, now this should be converted to radians first. Hence, so to convert this to radians, so let me say this is going to be degree value what I'm going to set, and let me use this degree value as d. So where d is going to be 45 degree right now. Fine, and now this should be converted to radians. Hence I will say radians equals, so degree into pi, that is 3.14, and divided by 180. This is the formula what I want to use to convert from degree to radians, and whatever the radians I have obtained from the degree should be passed as a parameter for the cos theta. And next I'm going to have minus, so the first point, that is v of 0, and I'm going to have the y value which is 1, and I'm going to multiply this with sine of the radian value what I'm going to have. This is going to complete my first equation for the x value of the first point, that is x value of the first point, y value of the first point. And when I compute this, I am going to store this as the x value of the first point with the rotation, that is the new point what I am going to find. So similarly, I am just going to copy this and I'm going to paste it over here. So now I need to find the y of the new point, hence so 0 of 1, and this is going to be now x value into sine theta. Now this is going to be sine of r, and plus this is going to be the same y value, but I am going to use this as cos theta, hence cos of radians. Now this is done. So now what about the z value? The new point, first point's z value is going to be same as the original value of the first point of the z value. That is what this is going to equivalent to this without any modification. And now this is going to be the first point, and similarly I should do it for the second point. I'm just going to copy this, and this is going to be the second point. This is going to be the 0.2, 0.2 and 0.2, the x y value z value of the new point, and similarly I should do for this. Now just wait. So instead of doing this, because if I'm doing like this, I should do it for the 8 times, because there are 8 points over here, and for all those 8 points I need to have 8 blocks of code. So instead of doing this in this way, can I make use of for loop? Yeah, that's the easier way to do this. Hence I'm going to use the for loop as I equals 0, I less than 8 and I plus plus. So open this for loop and bring this block of code now inside the for loop. And now this is of no use. And now instead of using this as I, so it says 0, we'll replace this with I. It's going to be I. And this is going to be I. Fine. So now this is how exactly we are going to do with equation. When this for loop is executed, all the 8 points has been updated. Fine. So now I'm using this r value over here, and even the r also should be declared as parameter. So let me save this and I will compile this. There's going to be error because I is the variable which we have not declared, so this should be declared. And so let me use this as int because it's just a for loop variable. I need not use glint. I can just use only as int I. We compile this. So now there is no further error. So if I execute this, I'm just going to add this as output. But if you just look, the cube is still intact. What's the problem with this? The cube, why it is still intact? This is because so now whatever the cube what I'm drawing, I'm using the old point only. You are not supposed to use the old point now because you have updated the point. You need to always use the updated value. Hence the rotated value what is you need to pass now. And this should be RV, not just V now. I need to pass the rotated vertices rather than just the static vertices what I found it at the starting point. So now by updating this, so compile this and execute, you can see the cube has rotated with 45 degree. Rotate with the 45 degree with respect to the Z axis. So this is how your transformation matrices is going to work with. Fine. So now with this, I'm able to rotate, but now I was supposed to spin this, right? Because the program is all about spinning. I'll just come back to the remaining axis later. So now when I talk about rotation, it was supposed to be spinning. So now how to bring in the spinning now? Now just look at this. When I say spinning, the degree will start from 0. It will go to 1 degree, 2 degree, 3 degree, 4 degree until 360 degree. And once it is 360, I can get back to 0 degree. Now this is where the spin is going to happen. Rotation, if I just give 45 as a constant value, it is going to be static rotation. If I want to bring in the spin, the degree value should keep on changing. Hence, I should not keep this as a constant now. Hence, this should be keep on changing continuously. Hence, for that case, so let me remove this d from this function and let me make this as a global variable, the degree as a global variable by initializing this value as 0. And now where do I change this value? And this is where the spin function will come into picture. I am going to make this d value as incremented by 1 whenever I am going to call the spin function. And when does the spin function will be called? The spin function will be called whenever the idle function is called. And idle function will call whenever your program will go into idle state. And when does your program will go into idle state? Whenever you are going to your display operation job is done. And that is where we are going to have the idle function. Hence, once the draw is completed, idle function will be called, the spin function will be called, the spin function now will change the degree from 0 to 1. And so once there's a change, you need to make sure the display function will be called immediately. Hence, we are going to call this a GLUT post redisplay. Once I call this, I am updating the value and I am going to call the redisplay function now. So now just check it out what happens. So when I am going to have when I'm going to change the value of degree from 0 to 1, the display function will be called now. The display function will be called. So where this display function will call intern the draw function. Draw function is going to update the rotation with the degree as 1 and is going to draw the cube and it will display it to the frame buffer and it will go into idle state. And once this will go into idle state, the idle function will be called, which calls the spin function. The spin function will be called, it changes the value and calls the post redisplay function, which in turn will call the display function. It will draw, go to idle, idle will be called. It will call the spin function, and now this is going to be something like in a loop. Hence, in a loop, this is going to work now. Now we'll just see whether the spinning is happening or not. Hence, I'm going to save this and I'm just going to, the spinning is going to happen. But if you just look at the spinning operation, it is going to be speed enough, or it should be controlled. It should be controlled with the value what I'm going to give. And for that case, so we are just going to reduce the speed by 0.25. From 1, I have reduced this to 25%. Reduce the speed by 25%. So compile this and save this, and now this is going to work fine with the spin operation. Fine, now this is going to work, but it's a good practice that you need to reinitialize the value of D whenever it is going to cross the 360 value. It will do it automatically for you, but it's a good programming practice in case if it doesn't works, if it doesn't handles. Our program should be able to handle this. Hence, when the value of D will be greater than 360, reinitialize this to 0 or the 0 degree. Hence, now by changing this, if I'm going to execute this, so this is going to work in the same way. Now this is going to be in a counterclockwise direction. This is going to be in the counterclockwise direction. Fine. Now this is how the spin is going to work. So now this is with the Z axis. So now similarly, I'm just going to copy this to make this to work with the x-axis. Fine. So now I'm not going to work with both the axes. I'm going to work with any one of the axes. And for that case, I'm just going to make this under the if condition. So if the axis what I'm going to choose, if this is going to be 1, then it should be the x-axis rotation. I'm going to use this as x-axis rotation. Fine. And if this is going to be the z-axis rotation, it should happen when the value of a is going to be 3. I'm going to have 1 for the x-axis rotation, 2 for y-axis, and 3 for the z-axis rotation. Hence, I'm just going to use this condition now. And so now I should declare a variable called as a. I'm going to have a variable called as a. So comma a, and let me say this as 1 right now because I want it in the x-axis. So now this formula should be changed accordingly. Whatever the x-axis rotation I'm going to have now, so this x value is going to be intact now. Hence I'm going to have x value to be intact. Hence I will make this as the x value, and this is going to be intact now without any change. And now this I want to be the y value, and this is going to be the z value for me. And so now for the y value, it is going to be y into cos theta, and so y into cos theta minus z into sin theta is going to be work fine. So y into cos theta minus z into sin theta, and this is going to be y into sin theta plus z into cos theta. Now this is going to work fine. So let me reorder this so that I'm going to have a proper programming structure. And so this is going to be the equation for the x-axis. Now we'll just see whether this is working fine or not. I've saved this and execute, and it's now keeping x as a strict constant now. Rotation is happening now. Is it fine? And this is how we are going to bring in the concept of spinning operation in this case. And now if I want for the y-axis, so similarly copy this and paste over here, and if the value of a is 2, I am going to keep the y-axis to be intact, and this is going to be x, and this is going to be z. So this is going to be z itself. And so now, or I'm just going to make this as z, and let me make this as x. So now for x, I'm going to have pz into sin theta plus px into cos theta. Now this is working fine. So now for the z value, I'm going to have z into cos theta minus x into, now this should be z into cos theta minus x into sin theta. Now let me reorder this. Let me reorder this with the x-axis value. I'm just going to reorder this. Even if you don't reorder, this is going to work, but it's a good programming practice. Later we can debug if any error occurs. So now this equation has been brought into this programming. I'm just going to compile this now and execute. Now this is going to be for x-axis, and if I'm going to change the value of a from 1 to 2, then I'm just going to have this as, yeah, this is working fine with the y-axis. That's going to work with y-axis. And if I'm going to give this as 3, this is going to work with the z-axis. Now it's working fine. So the spinning is working fine. The one thing what I should do is, every time instead of changing the value of a over in here, so now what exactly I should do here? I need should be able to get the value of a, and it's from the main function. So let me say printf. I'm going to have printf, and I'm just going to say enter the axis of rotation. Fine. And where? So 1 is for x-axis, and 2, enter 2 for y-axis, and 3 for z-axis. So depending upon which axis rotation you require, so that value should be entered here. And now whatever the value we are going to enter from the console, so just say scanf %d comma address of d. And so now d I am using in the main function also to read the value. Hence instead of making now d as, so this is going to be a, so this should be a. So I'm making a as the variable access in the main function. Hence I should be able to make use of a as globally. Hence I'm going to declare the variable a as global variable. Hence I'm going to have this as int, and I'm going to have a. So I'm not going to share this anything, or I can share this with 0, because at this point no rotation should happen. Hence I'm going to have a as 0. If I want rotation, I'm going to enter any one of the value. If I don't want any rotation, I'm going to apply 0 value. Right? Hence even I can bring this. So I'm going to have 0, and I will just say, so no rotation. Fine. So almost our program is done. Fine. So save this, and I'm going to compile this and execute. So now if I'm going to give the input as 1, and if I press enter, the rotation is going to be in the x-axis. Fine. And if I execute, and if I'm going to give the input as 2, this is going to be in the y-axis. Similarly, it is going to be with the z-axis. And if I'm going to enter 0, so the cube is be displayed unstructurally without rotation. As there is no rotation, hence the cube is going to be disrupted. And so make sure you're going to add the 0, and just check out what problem it is causing when I'm going to have 0, because when I'm going to enter 0, so none of this condition will be true, and this RV is with some values. That is, this RV is not initialized. It's not all initialized because none of the condition will be true. And so if this is the case, then you need to call the cube. You need to call the cube with the value whatever the virtual v value I'm going to have, not with the RV value. So later on, if you want, you can update the program with the changes what I made. You can see the sort of output, but I'll just not do it right now for you. You can do it later. Fine, now this is going to be the complete program. So where I'm going to have rotation in any given axis. And so just check it out for the Z axis for 3. This is working fine. Now this is what you're going to have a color cube which can spin in any axis using the transformation matrices. So this is all for this session. Thank you. Thank you for watching, and if you have liked my explanation, so you can put it in the comment box, and for further such explanations you can subscribe and follow my channel. Thank you.